about evaluation of water permeability of a single crack in fracture concrete. My topic is divided into 6 parts. The first part is background. As we know, concrete is widely used construction and building material. According to mechanical and durable performances in their service life, a better design should be selected first. With analysis in different scales, such as the physical and chemical process in the micro scale, and the fracture failure mechanism, and the thermodynamic in meso scale, and the macro scale. In macro scale, the mechanical performance and durability is pay more attention. That is, from material to the structure is our research purpose. As we know, the concrete is always would depend on the mechanical properties, and the durability is always focused on the trade-off between quality and quantity of carbon concrete. And then, well, there is a crack on the carbon concrete. There will be more aggressive agents, such as the water, carbon dioxide, and oxygen or chloride ions into the concrete from the crack into the concrete, and then the durability and the mechanical performance will be get the further deterioration. Then there will be the water permeability test was used to evaluate the durability of structure, and then we always test the materials, such as we always test the correct concrete specimens in the lab, and this is the material, and then we could select the good performance design to the into the field for the structure. And then talking about the water permeability, as we know, we always use the water permeability based on the cubic law. As about the cubic law, there are some basis should be talking about. And then because the cubic law is always ideal situation. However, a cracked concrete, such as the cracks, it is not the ideal. It's not follow the ideal situation. About the cubic law is the simplest situation of with parallel and smooth place model. It is the simplest situation from the Navier-Stokes equation. Then we will with some special in the general form of the Navier-Stokes equation. There will be internal first, field first, and external first, and the viscosity first. We always assume the crack into the 2 parallel smooth plate, and then we with no flow boundary and no slip boundary, the steady state water flow through the crack, and then we could get the water only in the gravity field with some mathematical calculation. Then the internal first is vanished, and then there only field first, external first, and the viscosity first is left. And then we could got the cubic law. About the cubic law, calling for the Darcy's law, we could got the permeability equation. Before talking about the permeability of cracked concrete, we should got some message about it. Before the concrete is, before there is a concrete on the before the crack on the concrete, that is the sound matrix without any cracks. There is minus 18 orders of magnitude. Well, there is a 10 microns crack was found on the concrete matrix, and then there will be 6 orders of magnitude increasing, which means that the cracks will govern the permeability of concrete instead of the proper structure of the cracked concrete. And then, based on the Darcy's law, we could define the water permeability of cracked concrete in lab. The capacity of a cracked concrete space to transfer water through a fully saturated and interconnected crack void space under a pressure gradient. And then, based on the cubic law's equation, and we could got some factors about from its parameters. The first is we could from the pressure gradient we could know that deduced from the devices and the crack width. There will be, we could thought about the surface roughness, obstacles, and crack tortuosity, and the crack grade. About the dynamical viscosity coefficient, it is the nature of fluid. And then we could thought about, we could think about the temperature will influence the nature of the fluid. It about the environmental factors, about evaluation indexes of the transport capacity. There will be the parameters about the permeability, transmissivity, and the hydraulic conductivity. Okay, before we're talking about the second part, a necessary message should be sent. That is, there is not a standard evaluated method to characterize permeability of cracked concrete. Then there are many kinds of devices used to evaluate cracks transmissive capacity. And then about the test devices, it could be divided into 2 kinds of types. The first type is the folding head test with low pressure, and the constant head test with high pressure. The former is always focused on the initial and final water head. However, the latter is always pay more attention on the collecting water fluxes. Just like from the equations, we could know the A is the cross section of the straight pipe, straight pipe's diameter, and T is the time, and this one Q is the water flux, that is the volume of water. L is the thickness of the spaceman. Then, even there are many kinds of different devices, and there are always many different structure. But something we should know is while the water permeability test was conducted on the cracked concrete, with the permeability of the crack, that is region 2, is our needed date. But the total water head, that is H, is always used to calculate the permeability. However, about region 1, region 3, and region 4, and from the region 1 to region 2, the extension, and from region 2 to region 3, sudden construction, and the canal bending, and the valve. There will be the fraction head loss and the local head loss. From the total water head and to the actual water head, there will be some error in between them. And then if we use the total water head to calculate, and then we could overestimate the permeability, like this picture. Well, larger the crack width is, and then the lower actual pressure gradient will be. And this picture is about the relationship between the Reynolds number and the actual pressure to total water head. There are two kinds of crack. First one is the artificial two parallel plates, and the second is real cracks. The real cracks is this point, like this means the Reynolds number, a higher Reynolds number past this Kramer value, then the actual pressure to total water pressure will be a larger error. A higher Reynolds number or a higher pressure could lead to overestimated permeability of crack. Well, the Reynolds number is larger 100 for the real cracks, and the artificial two parallel plates the devices are revealed there, which are designed with different rigid purpose. For example, the device 4 is designed for testing water permeability of spacemen with unrecovered crack width. Although there are many kinds of different devices, they are all follow the two types. The first one is the first type is the constant water head test, and the second one is the flow head test. Although there are many different kinds of devices, they always pay more attention on several points. The first point is recording time and the test type. And the third point is saturated conduction. And then we could select a case of testing crack permeability to talking about. The permeability measurements were taken at time passing 2 hours. Passing 2 hours after first filling the water tank to obtain the steady state water to obtain steady state flow and to minimize the influence of self-healing. About the steady state flow, we will talking about more in the third part, the environmental factors. This is a simple model to talking about several situations about the water flow, the crack. There will be a process from the unsteady state flow to the steady state flow. There will be 3 different factors to influence the water flow rate. And according to research Mao, he present that a fully saturated situation always means that a capillary pore pressure is 0. Then, how the capillary pore pressure influence the tested date? Like this picture. We always talking about the Poisson's law. It is a straight line. It's parallel with the x direction, time direction. It is a constant water flow rate. However, this blue line under the capillary pore pressure and the external pressure, it is a higher flow rate, and then it is tended to the stable. It means there is a unsteady state flow to the steady state flow. Then, in order to research the time to get the steady state flow, he took the repeated tested for after drying every 12 hours. The first, he took the first test. Is about it took about 30 hours to get the steady state flow, and the second test is corresponding to 20 hours, and the third and the fourth is about 8 hours to get the steady state flow. Which is mean the former tests is help the crack to get the partial saturated, and then if the crack is under the full saturations, and then the capillary pore pressure will be cut down to the 0. Just is all the Poisson's flow. However, even the capillary pore pressure is cut down to 0, and then there will be a roughness influence. It will reduce the water flow to the crack, and then there will be another test to exclude the influence of self-healing on permeability of cracked concrete. And he took the perspex sheet crack and word to test. It shows that it took about 20 hours to get the steady state flow. About unsaturation is corresponding to the unsteady state flow, and saturated situation is corresponding to the steady state flow. And why? It means, well, there unsaturated canal path, there will be capillary force to drag the water through water head higher. And then, well, the crack, all of the canal path on the crack surface, that is being pink, like this picture. Then the capillary force in the crack will cut down to the 0. And the second factors about the environmental is temperature. The temperature influence. The first is well, the temperature increasing, and the dynamical viscosity coefficients will decrease. And then from 1 hour to 48 hours, there will be the initial permeability was cut down to about 1/10. The data from this lecture and was into this table. It shows that all of the data is less than the predicted data. This one is as well. It could be explained that there will be self-healing effect on between the cracked concrete and the water, and with the temperature increasing, and the larger self-healing effect will be. The first part is in order to talking about crack geometries of concrete. Well, a crack was found on the concrete matrix. We always the crack width is always thought about. However, there will be a connector region. That is the obstacles, and the surface roughness. As we know, the cubic law is based on the two parallel and smooth plates. However, a real crack is always cannot be an ideal situation. There will be surface roughness and crack tortuosity, and how they influence the transport capacity. Well, the water flows through the real crack. Well, the pressure and the Reynolds number is higher. It will result in the eddy flow, and with the higher Reynolds number, the eddy flow is the eddy flow aperture will be large. It should to know the transport capacity is only associated with advective flow aperture, and that means while the water flow the two parallels and smooth plates, the eddy flow cannot exit in the crack. About the crack width, it's always got the surface crack width to test it, and it is always in phases the crack width field. It is a 3 dimensions measurement. It's not a surface test. About the crack width field, there will be a typical width. That is the effective crack width. And Yang provided his calculated model, and Akven give another equation. Okay, about Yang, he provided a model to calculate part of crack, and then give integral form to calculate two different directions equal effective crack width, and then give a geometric mean value. About Akven, he provided a calculated model. He assumed the real crack into the many boxes to connect it, and then there will be many little cubic that is the little parallel plate connect. As we know, it's very difficult to deduce the effective width. Then the relationship between the surface width and the effective width was researched by Akven. He illustrated that the average surface crack is more accurate than LVDT's reading. As for characterizing crack surface roughness and crack tortuosity, a statistic was used. That is, a laser scan was used to obtain the surface morphography data and then reconstruct the crack geometry in MATLAB. The roughness and tortuosity are tested in 3D topography and a 2D fracture model with upper and lower profile. About the influence of crack surface, Mark give his result. He presented that with a rougher crack surface, there will be a lower transport capacity. With the explanation of Zhou, he presented surface, a rougher crack surface will result a lower advective flow aperture and larger eddy flow aperture. This result the lower transport capacity. And then about the crack geometric between there are two kinds of mathematical model to calculate. Okay, a real crack. There are about real crack. There are two kinds of mathematical models to evaluate water transmissivity. Outplate tortuosity was taken into this the first model, and in-plate tortuosity result from the obstacle was taken into the second calculated model. It was took the obstacle L to the total L's ratio into this into calculating. And while there is a real crack, there cannot they are not just surface roughness and tortuosity in the crack. There will be many obstacles in crack void space, and then how the crack void, how the obstacle influence the permeability of crack. Research from Chen, he provided, well, there is not any obstacle, it will result a surface flow. Well, there are many obstacles in the crack. There will be many, the surface flow will transform to the canal flow. It will result a test deviation between the cubic row and the experimental date. Between the two date, there is a decrease between the same K-share fraction. A further discussion is well, there are many obstacles in the crack void space. It will result many streamlines with different interconnected crack void space paths. It could be explained that with obstacle in the cracked void space, there will lead to the cubic row to will leave a deviation between the cubic in the cubic row. The in the cubic row, the internal force is 0, and while the internal force is not 0, the cubic row will get the deviation. About this picture, it's about crack width and crack permeability. Well, there are many data is from the water permeability and different lines are from crack geometric test with a predictor mathematical model. Well, there are same crack width. There will there will different results between the two lines. Even they are same crack width. About the fifth part is talking about evaluation on transport capacity. As we talk about the devices, about the pressure gradient, it could be expand the actual pressure by a predicted test to got the actual word head. And about the crack geometries, should be take the obstacles, crack width, and crack tortuosity, and surface roughness into account. And about environmental factors, steady state flow should be taken into account. Well, we give the evaluation to the transport capacity of crack. There are a modified cubic row should be used. Finally, is the conclusions. The first point is a standard water permeability test on cracked concrete should take the devices and environmental factors into account. Otherwise, crack geometric parameters could influence the permeability of cracked concrete. And the second point, it cannot record the result until the steady state flow is observed, and the recording time should be confirmed with different devices, and from the research from different researches. It could conclude that you cannot record until it is a steady state flow. And the third point is effective pressure should be tested and confirmed on crack, because exciting fractional head loss and local head loss resulting overestimation. The first point, a hydraulic width can be predicted by the testing crack geometries, which means hydraulic properties of a single crack can be deduced by measuring crack geometries. Okay. Thank you very much. That's all. Thank you.